Hello viewers, welcome back. In this tutorial we are going to learn how to classify handwritten digits through deep learning. So the model which we are going to use, let's see the model out there. So you can see this is I can consider this layer as input layer where there will be around 784 neurons, and in these layers this is the second layer. The first hidden layer I will be having around 128 neurons out there, and in the second hidden layer I will be having the same number of neurons, and in the final layer I will be having I will be having 10 neurons for 10 predictions. Now uh, if I think about the connections of each layer, I will be making connection that is densely connected, which where each neurons of one layer will have connections with each neurons of the second layer. Okay, so this one here, this single neuron out there has connection with each of the neurons in the second layer. This is called densely connected layer. Similarly, here I will have densely connected layer, and here I will be having densely connected layer. And if I talk about activation function, here I will be using ReLU, same ReLU, and here I will be using softmax. So let's begin. Let's go for code. So import TensorFlow as TF and write mnist out there equal to tf dot keras dot datasets dot mnist. So I will be having the mnist dataset, and now let's load the dataset. So write out the x train, y train, x test, y test, write out there mnist dot load data. So I am loading the data. Now if I take the help of matplotlib, so let's import matplotlib dot pyplot as plot. Fine. Now let's print one of the image out there. So plot dot imshow, write out there x train, first image out there, and cmap equal to write out there gray. Okay, now plot dot show. Now I also want to see the prediction out there, the label out there, x train, x train 0. Okay, so print this one. Now run the code. So let's run the code. So you can see this is an image, and where it is 5 handwritten 5 out there, and here is the prediction of 5. So now I am going for, what should I say, so let's go for further. I have shown this one, just with this out. Now I will be creating my model. So for creating model, just write out there model equal to TensorFlow tf keras dot models. I'll be creating a sequential model. Okay, so now model dot add, right, add out there. Now I'll be adding keras dot layers dot flatten. So the first layer I will be having the number of neurons equal to the images here. So let's say I have an image of 28 by 28, and if I flatten that, then I will be having 784. So the number of neuron in the input layer will have 784. Now model dot add tf dot keras dot layers. Now I will be having densely connected layer. Okay, so dense, and I have to give the number of neurons out there. So just give 128 and give the activation function out there. Activation equal, I am giving tf dot nn dot value. Okay, so if I see this activation function, let's see the image of this graph of this activation function. So this is a ReLU, that is rectified linear unit, and anything greater than 0 will be passed out, and anything less than 0 will be turned as 0. So this is my activation function out there. Okay, fine, and again give another layer out there. So I will be giving the second hidden layer. So Tensorflow keras dot layers dot dense, and I will be, let's give again 128. Oh, okay, you can decrease too, so let's give 100. Okay. And activation equal to, I will be giving again tf dot nn dot. So now I have to give the last layer, which is for output. Now I have 10 prediction out there, so I will be giving 10 neurons at this site. So add tf dot keras dot layers dot dense, again densely connected, and I will be giving 10 neuron, and as activation function I will be giving softmax. So tf dot nn dot, give out there softmax. So this is the softmax out there. Now I have created my model. So this model out there is created here. Now I want to give some compile. So I'll be giving the loss function and the optimization. Okay, how it will be, the model will be optimized, and how the loss function will be. So let's see, compile. So optimize. So give out there, optimizer equal, I'll be giving, what should be given, let's give Adam. So basically the Adam optimizer is by default very if you think as a default optimizer. So this is a default optimizer for neural networks. You can choose other two. For this neural network I am choosing Adam. And as loss function, since I have to classify into 10 categories, for that reason I will be using sparse categorical cross entropy, and you can choose like binary cross entropy for binary classification. Okay, now matrix. So matrices which I want to track accuracy. Okay, I am done with the model. From the next tutorial I will continue from here. I will do the evaluation, I will feed my model and show graph of my outputs. So this is all for this tutorial. See you in the next one. Thanks for watching.